Hello everybody, welcome to Physical Science Day. We're going to be studying, as you can see, the atom in the periodic table. I think you'll like these notes, because the atom is the smallest piece of matter that still retains the properties of the elements. Okay, so we already talked about the atom, right?
Yeah.
ATOM, the atom, is the smallest piece of matter that still retains the properties of the elements. Okay. Now these notes are online if you want to just write them down now. A lot of people like that. Or you can print them off too. Look, it takes 24,000 atoms stacked to equal the thickness of aluminum foil. Okay, so that's like really small. Because aluminum foil is really thin. 24,000 atoms in that much thickness is really small. Look, atomos, Greek word, it means indivisible. And this guy right here, Democritus, in 440 BC, he said, there's got to be something that we can break down. If we take something and break it down, split it in half, there's going to be something that when we get there, we can't split it in half anymore. And that's what he calls atomos, which means indivisible. We can't split it anymore. That's where this word atom comes from. A-T-O-M. Not atom like out of the earth. That's Adam, A-D-A-M, out of the earth. This is atom, atomos. Okay, but we found out later though, after this guy was really advanced for 440 BC, but we did find out later that we can split the atom. We'll talk about that later. An atom is composed of a nucleus. Okay, so you talked about nuclei, which would be plural for nucleus, N-U-C-L-E-I. Maybe another I. But anyway, nucleus is one, and it's a very dense central core of the atom. If it was the size of a grape, it would weigh 9 million metric tons, which is 1,000 kilograms, which is 2,200 pounds, times 9 million. Size of a grape. One more. Okay, proton is inside the nucleus. A proton has a positive charge. A neutron is inside the nucleus. A neutron has no charge. So a proton and a neutron walked into a bar. A fruit bar. A fruit juice bar. Oh yeah. So, electrons, notice, electrons number 2. Nucleus number 1. Electrons are not in the nucleus. They are not part of the nucleus. But they have a negative charge, and they're found in clouds of probability around the nucleus. So what they say is, hey, there's a volume of space around the nucleus where you might find an electron at any time. That's what is the cloud of probability. That's what scientists today are saying. So, the electron here is the thing that has no specific location. The electron is in constant motion. So an electron cloud is what determines the atomic size. And if you look on pages 108 through 110, it'll kind of show you how an electron cloud determines the size and the shapes of it. I have an assignment for you that'll make you do that anyway. And electrons are then found at certain energy levels. So there's 7 energy levels that we have identified that encompasses all of the atoms on that periodic chart. So there's only 7 different energy levels that you can find electrons in for all the atoms. Okay, look, each level can have a certain number of electrons. And if you look at page 108, it'll tell you the first energy level can have 2, the second energy level can have 8, the third energy level can have 18, the fourth energy level, 18, and you'll be able to look at the pattern and see that on page 108. We'll talk about that more. Okay, Metrodome. Why do I have that there?
Because it's a code.
It's a metronome.
Because look, hold up your thumb and go like that so you can just see the part that has a nail on it. Okay, so that part right there, some people can take it off, right? I don't know if I can. If you could take that part off and hold it in the middle of the metrodome. Do you guys know what the metrodome is? Do you know what the...
You can see your
Do you know where the Minnesota Vikings play? That's the Metrodome. Have you heard of the Mall of America?
Yeah.
Okay, so take that much of your thumb and put it in the very center, hovering in the middle of the Mall of America or the Metrodome.
Oh, yeah.
Where's the first closest electron?
Outside.
Outside of it. Is that crazy or what? So that means that you're mostly, or the dog park, if we're right here. So you guys are mostly spaced out. Okay, quarks. Quarks are what they have now determined. They decided to call the things that make up protons and neutrons quarks. Quarks. There's 6 types of quarks. So there's up, down, there's lucky, there's charm, and there's 2 others I forgot the names of. You guys have heard of the Large Hadron Collider, right?
Yeah.
Well, before that, there's this thing called the Tevatron, which wasn't that big, as that. And so they took things and they accelerated them with electromagnetic, with electromagnetics, and they smashed them into, so they smashed protons into other atoms, and that's when they actually could tell that you could break these atoms down into something smaller than what we thought was indivisible. And they could even find out then that the protons could be broken down into something smaller than what the nuclei were made of. So this is like the precursor to the Large Hadron Collider, the Tevatron. Okay, so now we just need to talk about the massive pieces. So when we're talking about a nucleus, there are parts in the nucleus that we call massive. Okay, so mass isn't weight, right? Mass is, remember at the beginning we said, what is mass? Well, mass is what everything is made of. Or mass is the measure of everything is made of, right? Or we measure mass in kilograms. Okay, so if you weigh something, you get pounds. That's a weight. If you mass something, you get grams or kilograms. So all these triple units are mass. They're massing units, they're not actually weight units. So where do we get our mass from? Where does our weight come from? Because like I said, I take Mac, I squish all the space out of him, he becomes so small I can't even see him. But you still have a lot of mass. That's what's so weird, right? AMU is atomic mass unit. Atomic mass unit. So this is, instead of kilograms, because these things are so small, we don't use kilograms, but we use AMUs, which is an atomic mass unit. That's the SI unit for the mass of any nucleus. 1 proton masses 1 AMU. 1 neutron masses 1 AMU. 1 electron masses 1800ths of 1 AMU. So we consider at this level, and your next chemistry level, and your next chemistry level in college, we consider the mass of an electron negligible, since it's like almost 2,000 times less. 1 proton. So if we look at hydrogen, there has 1 proton, it has a mass of 1 AMU. If you look at helium, it has 2 protons, 2 neutrons, it has a mass of 4 AMUs. We're going to talk about that a little bit more. But for now, write this down and memorize. Okay, so this C is nothing you have to necessarily memorize. But when we're talking about these symbols that we've been talking about, all the symbols that you had to memorize for your symbols equation or your symbols list, what's mercury? Hg. What's gold? Au. What's lead? Pb. Right. So a lot of these symbols were named using Latin words, people's names, a college where they were discovered, a country where they were discovered. Okay, so these are some examples of all those atoms on the periodic table.